Hello class 12th. In this lecture, in the previous lectures we have completed our chapter 18 optical instruments and we have solved some numericals. You're not putting any question, any query, so I'm moving to the next chapter, that is wave nature of light and Huygens principle. Wave nature of light. Just remove the wave word. What is remaining? Nature of light. So what is the nature of light? Wave. Who said? After this chapter you will come to know who said that light is a wave. But before that, what is light? Light is a form of energy which gives sensation of sight. And if you want to say that light is something, or whatever the light, suppose in this chapter it is talking that light is a wave. So if light is a wave, so you have to prove some phenomena by considering that light is a wave, and that phenomena are refraction, reflection, polarization, dispersion, rectilinear propagation, and many more examples are there. You have to prove all these. If you are able to prove these phenomena successfully, means the light is wave. But according to Newton, he was saying that light is made up of very tiny particles, that is called corpusculars, and using this topic he made the theory that is called corpuscular theory, and the tiny particles were named corpuscles. Again, to prove your topic, means if Newton is correct, so he have to prove all the phenomena. He was able to prove all the phenomena except polarization, diffraction and interference. If he was failed to prove these phenomena using his theory, means the theory was failed, then Huygens came. So according to Huygens, he was assumed that light is a wave and it can travel in all directions with the speed of light. And we know that light requires medium to travel, so he considered a medium called luminiferous ether. This is considered that this medium is weightless and it can penetrate through any medium, any matter. But now point is, what is the Huygens principle? Means this was just a theory that light is a form of wave and it travels with the light, speed of light, that is 3.8 meters per second. So he gave some principle, but before going to the principles, Huygens principle, you must understand some points. The first point is called wavefront. What is a wavefront? Just listen carefully, this is very difficult to understand. Suppose here the light is also here. So here I am imagining a surface of any shape you can see. I am taking a rectangular shape of surface. In this surface there are many particles. They all are vibrating. If in this surface all the medium particles are oscillating in same phase means this point and this point, these are vibrating. So see, it means they are in same phase. Means suppose there are 8 particles, all are moving with same motion, means they are performing same oscillations. So in this surface, if in this frame, in this surface, all the particles are oscillating in the same phase, then you will say this surface is what? A wave front. What is wave front? A surface in which all the particles are vibrating with the same phase will be called wave front. So again, to describe about wavefront, suppose this is a light source. This is spreading its light in all the directions. A point bulb you can also consider point source. It is spreading its light in all the directions. So I am taking one surface around it in the form of circle. Since the light is spreading in all directions, so you must consider the sphere. But I am showing you with a circle. So you must consider that this is sphere. So if from the point object the light is traveling to the surface, suppose by 2 wave, after completing 2 wave. So here is also completing 2 wave, in this direction also 2 wave, in this means in every direction the light is covering two wave distance. So this circle is a constant distance from the point source. So means in this circle, in this surface which is spherical, all the particles are in same phase. If all the particles are in same phase of this circle, and actually this is the sphere, so this surface is called wavefront. So we have seen the point object produces a spherical wavefront. What is wavefront? In that surface all the particles oscillating with same phase. So point object produces spherical wavefront. Second, suppose the light is coming from infinity at very far distance. So what will happen? Same thing, just see this point object producing circle. Just increase the radius of this circle. If you will increase the radius of this circle, what will happen? At some time you will say this arc is a straight line. So which form of wavefront it is? Plane wavefront. And where is the object? At infinity. So if the light wave is coming from infinity, so it will produce plane wavefront. Next, suppose the light source is of tube light, a rod. This tube light will produce light, means wavefront, in the form of cylinders. In the form of cylinders. So you can say cylindrical waveform. So if you are able to know the shape of wavefront, so you can say the direction of wave also, the direction of light also. How? Suppose we are saying that the plane wavefront or any wavefront, just draw a perpendicular line on that wavefront. The perpendicular will give the direction of light. In the example of sphere, when the object was point source, so the radius will be what? The perpendicular on the circle. So whatever the direction of the radius will give you direction of the light of propagation. If that is plane wavefront, so you can say that light is coming parallel, perpendicular to the surface. And if the light is originating from the rod, so there will be cylindrical. Again, whatever the points, whatever the perpendicular you will draw will give the direction of light. Now I'm going to explain about the Huygens principle. So first point by the Huygens principle is, you have seen the wavefront. So according to Huygens, every particle in the wavefront acts as a new source and originates the new wave that's called secondary wavelets. So every particle in the wavefront acts as a new source of wave from which the new wave will originate, and that new wave will be called secondary wavelets. What is mean that? Again see, point object, a wavelet. This point object produces wavelet, this point source. This wavelet will contain many particles around it. Take any particle. This particle is where? In the wavefront. This particle will originate a new wavefront, new wave source. Suppose one more circle around it, because it is producing the new light source. So this circle, the new circle, now it will be called secondary wavelet. And again, in this circle, one more point will be there, many points will be there, and you take any point, again a new circle. So this will be secondary wavelet for this, and this first circle is called wavelet. This is called wavefront. This is wavefront. The first circle is called secondary wavelet. Second circle will also be secondary wavelet, but for this second circle. And this second circle will be wavefront for the second point. Wavefront, then secondary wavelet. Now this secondary wavelet will produce further secondary wavelets. In this way, the light produces ahead. This was the first point. What? Again listen. Every particle in the wavefront will act as a new source from where new wave will originate, and these waves are called secondary wavelet. Second point of the Huygens principle says that the secondary wavelets produced from the wavefront will travel with the same speed as the wavelet has. Means it will, if the wavelet is traveling with the speed of light. So second wavefront is, if the wavefront is traveling with the speed of light, so secondary wavelengths will be having same speed of light, will travel with the same speed of light. Means again I'm speaking, the new wave source originating from the wavefronts will have the same speed and will travel in all the directions. The third point of the Huygens principle is that the envelope of the secondary wavelet in the forward direction at any instant gives the new source of wavefront at that instant. So you have seen the 3 points of the Huygens principle. One was saying that in the wavefront all the particles originates a new wave source, that is called secondary wavelet. Second thing, every source will produce the new wave source, that is with the same velocity as of the original wave. And the third, the forward direction, the secondary wavelets, direction of the secondary wavelets in the forward direction gives the direction of new wavefront. So to understand that, see the 2 diagrams. In the first diagram, you will say the AB in the curved shape, in the spherical shape, means this AB is started from the point source. That is why AB is in the form of spherical surface. Now see the second diagram, straight. It means this was made by the light which is coming from infinity. That is why AB is straight. Now this AB means either curved or straight. If I'm talking that these are wavefront, so every wavefront is having many number of particles. So I'm taking some particles, suppose A, B, C, D, small a, B, C, D, whatever it is. The ends I have named with the capital AB, and in that particles, small a, small b, or you can say 0.1, 2, 3, 4, whatever you can consider. So this particle in the wavefront will act as a new source. So suppose the new source will be a point source here right now. This spherical is produced from the point source. That plane is produced from the infinite source. But the particle which are lying in that wavefront will be like point source now. Now point source will produce a spherical wavefront. Now see, spherical wavefronts around all the particles. Now the envelope means a tangent drawn over that line. This is the direction at the secondary wavelet. So A dash B dash is what? The secondary wavelet here in the spherical and the plane also. So if the waves are originated from point source or plane source or anywhere, after some time in the secondary wavefront will be spherical, that will become point source. So after this, if light is a wave according to Huygens, so we have to prove all the phenomena like refraction, reflection, interference, diffraction, and many phenomena. So let's see the first phenomena, the reflection of light using wave nature of Huygens principle. Let's see. So first one that we are going to derivate the law of reflection using Huygens principle. So let's draw the diagram. Considering SS dash is any reflecting surface, and this AB is the incident plane wavefront. This is coming from infinite, so this one is the plane wavefront coming towards this reflecting surface. So the perpendicular drawn on the wavefronts are called the ray. So I am drawing the 2 rays here and here, the perpendicular on the wavefront. Again listen, this is AB as a wavefront, incident wavefront, this is the reflecting surface. We have to prove the law of reflection. So the perpendicular drawn on the wavefront is known as ray. So here are the 2 rays, and a perpendicular, say N, and the angle of incidence, incident ray, and the normal between them, the angle of incidence. Now see, this is perpendicular on this wavefront, this ray. So this complete this complete is 90, and this normal is also perpendicular on this surface. So this complete is 90. So this one is common. So this plus this is 90.
So this plus this will also 90, and this one is common here and here. So this angle will be equal to also angle I. Again listen, this complete is 90 from here to here, and from here to here also this is 90. This one is common. So this plus this is 90. Same way this plus this will be 90. So this one is what? Angle I, and this one is common angle. Now after this what will happen? So this is incident rays. So we can say this is the incident wavefront. So this will come toward this way. After this point, this ray will continue to come here, but this ray, what will happen? This will reflect. Same way other rays also, as this one is going to reflect, the other rays will come up to here and then will reflect. Some will come up to here, then it will reflect. So the last one will come to here, till the time this will have the same distance in somewhere in this direction. So I am drawing in this as well as this one also. So you have seen, by the time this ray is coming from here to here, this ray is reflected ray is going toward this. So further, let's say this point is A dash, and here you know that this distance is from here to here and equal to this much. Suppose we don't know this distance, that distance traveled from B to A dash, from B to A dash, if I don't know from here to where it is. So let's draw it further, because suppose I don't know the distance traveled from B to A dash is from A to where up to. We don't know from up to where, from this equal to on this line. So what to do? So equal to this arc, the suppose whatever the distance is, this same arc, just cut it on this line. And how? Using any compass. Let's see. So here I have drawn an arc B dash such that B to A dash is equal to A to B dash. Again, to understand this, when this wavefront striking at this point, the AB wavefront is touching at this point. So this point, this wavefront will originate the new source. So this will produce the spherical wavefront like this, like this. So suppose this one is the last one. For this one, in the same way, the ray after some time it will struck here, the ray which is coming toward this point, the same way it will also produce the spherical wavefronts. In same way, every point will produce a wavefront, every point, and one of that arc is this, like this. So if we will draw a common tangent on all these secondary wavelets, these are what? The wavelets, these all are. If you will draw a common tangent on the secondary wavelets, so this common tangent will be what? The reflected wavefront. This is what? Incident wavefront, and this is what? Reflected wavefront. We are going to prove this, but here we are not going to draw for every point, for every secondary wavelets. We can consider this is the wave tangent. So we will draw a common tangent for all. We are considering that all the secondary wavelets have been drawn by every particle here will come to here and will originate a new wave source, and this will have the common tangent from here up to here by taking only one. So I'm drawing the reflected wavefront right now. So these circles, that was secondary wavelets, will have common tangent, that you know, that envelope. So that is the tangent, common tangent, one of which you will be seen here because it is started from here. By the time this ray was coming up to here, the same time it was producing the secondary wavelets of longer and longer radius. So up to this it is reaching. So this is the common tangent for all these secondary wavelets. So this A dash B dash is what? Reflected wavefront, and this one is what? The incident wavefront. So if this is the reflected wavefront, so this will be having the angle R. Now let's do the proving. For this, the distance traveled, suppose this is the medium air or any medium, and this light is traveling with velocity, I'm taking with velocity v, I'm considering these rays are traveling with this speed v. In time t, this is coming up to here from b to a dash. I'm considering that in time t, it takes time small t to reach here. So distance a dash b is equal to velocity into time. Velocity is v into time. I'm taking the time taken from here to here. In the same way, the time taken, the distance traveled will be same here also. In the same time, in time t from b to a dash, in the same time it is coming from a to b dash. So a b dash is also equal to v into t. You can see here from b to a dash, I'm considering it is taking the time t. So velocity v, the distance traveled vt. Same way, in the same time, the light is going from here to here, the rays are going from here to here. So a b dash is also equal to vt. Now let's see in this diagram, in this triangle BAA dash, in the triangle BAA dash, use sine I. This is 90, means this is hypotenuse. So sine I is equal to perpendicular upon hypotenuse. Really, sine I is equal to BA dash upon A dash, BA dash upon AA dash, perpendicular upon hypotenuse in this triangle BAA dash. Now in this triangle B dash A dash A. Now see, B dash A dash A, B dash A dash A in this triangle sine R, perpendicular upon hypotenuse, B dash A upon AA dash. See this one. Now let's do sine I upon sine R. So value of sine I, BA dash upon A dash, value of sine R, B dash A upon A dash. A dash will be cancelled. Then what is remaining? BA dash upon B dash A. But see here, this BA dash is V into T and AB dash is also V into T. Both are same. So let's fill the value. This is also V into T and this one too, V into T. Means they are cancelled. What is here right now? 1. So sine I by sine I is equal to 1. Or we can say sine I is equal to sine R, as sine I by sine I is equal to 1. So sine I is equal to sine R, or the angle I is equal to angle R. This is what? Nothing but the law of reflection. The law of reflection says the angle of incidence and angle of reflection both are same. This is the first law of reflection, and here we have proved, means considering that the light is it's a wave. So we have proved the law of reflection, means our assumption that the light is a wave is proved in this reflection. In examination, it is used to us to prove that the law of reflection using Huygens principle. So we have proved here that I is equal to R. And if we want to prove the second law also, so we can see here the incident ray, means you can say incident wavefront, the reflected wavefront and the normal, all are of them in this plane. So second law is also proved. So in this way we can prove the derivation of law of reflection using Huygens principle is done.
Here I am ending this session. In the next lecture we will discuss about the refraction, because wave nature, if you are considering that light is a wave, so we have to prove the reflection, that we have proved. Now we have to prove refraction. So in the next lecture I will prove about the refraction using this wave theory of Huygens and furthermore topics. Till then, be safe, take care and do solve the numericals. Thank you.